Now that we've examined the structure, functionality, and key methods of Java CountDownLatch, let's take a look at an example application. This application will illustrate how to program Java CountDownLatch in practice. This is actually an Android app that's designed to use two CountDownLatch objects to coordinate the concurrent benchmarking of 4 greatest common divisor, or GCD, algorithms. GCD computes the largest positive integer that's a divisor of 2 numbers. For example, the GCD of 8 and 12 is 4. There are 4 algorithms tested as part of this app. When the app runs, the algorithm performance is actually visualized as shown in the diagram screenshot on the right-hand side of the slide. One algorithm is the GCD method defined by the big integer class. Another is the iterative Euclid algorithm, which you can read about at this link. There's also an implementation of a recursive Euclid algorithm. And finally, there's a very complicated GCD algorithm that uses binary arithmetic, which is called, I believe, the Stein algorithm. And as these algorithms run, they're visualized in the display so you can see which one performs best. I have a 4-core simulator, so each of these different algorithms is actually running in its own thread on its own core. The details of these algorithms are not important for our discussion, but feel free to take a look at the source code if you're interested in knowing how they are actually going to be implemented under the hood. Let's take a look first at the GCDCountDownLatchTest class. This is a JUnit test that creates worker threads that use entry and exit barrier countdown latch objects. You can see here that we go ahead and call the makeGCDTuples factory method, which initializes the data structures that hold all the GCD algorithms. We then create an entry barrier, which starts out with a countdown latch value of 1, and the main thread's going to use that in order to tell the other threads that they can continue. We then create an exit barrier, and this is used by the main thread to wait for all the threads running in the background to finish. And because we're going to have 4 tests in our GCD test list, the GCDTest.size method will indicate the size or the count of that countdown latch for the exit barrier. We then go ahead and use the Java 8 for each method to iterate through all the GCD algorithms one at a time. And we go ahead and create a thread that will run an instance of the GCDCountDownLatchWorker class, which I'll talk about in a second, passing in the entry and exit barriers. And this new thread is then started. So we'll have, in this case, 4 threads all running in the background after this loop runs. We then print out a little diagnostic message saying that the tests are started. Although the worker tests don't start just yet, even if they've been created and have been up and running as a result of being started in that previous loop. Instead, all those threads will have to wait for the entryBarrier.countdown method, which will let all the worker threads proceed at that point. Now, what's kind of interesting about this is the countdown method, as you may recall, is just a latch. And this latch lets the worker threads start running. But it doesn't work as a barrier. In particular, it doesn't ensure that all the worker threads start at the same time. So as soon as the countdown method is called, after that point, any thread that starts can go ahead and do its thing. But the countdown method will not, those other threads will start running as long as countdown has been called. We'll talk later about how to fix this problem in the, or this limitation when we talk about Java cyclic barriers. The exit barrier works completely as expected, though. This causes the main thread to wait for all the threads to finish that are running in the background, doing the GCD computations, and this call will not return until all the other threads have finished. After await returns for a countdown latch, it can't be reused or reset without creating a new countdown latch instance. So that's the overview of the driver program. Now let's take a look at the GCDCountDownLatchWorker class. This class applies 2 entry and exit barrier countdown latch objects to coordinate the benchmarking of a given GCD algorithm implementation, such as the iterative Euclid or the recursive Euclid or whatever the ones they are. As you can see, this class implements runnable, so it can run in the background in a thread. The various barrier fields are initialized by the constructor, and then it has a run hook method that actually starts to execute after the thread is is run or started. When that runs, the first thing it does is it checks to see whether the main thread is already called countdown on the entry barrier. If it's not, it'll wait. If it has, it'll go ahead and start to run. Notice that this, as I mentioned before, will not cause all the worker threads to block waiting for everyone to start. It just waits for the main thread to start. And we'll talk about how to solve this problem in the Java cyclic barrier lesson that's coming up. The run test method actually runs the GCD algorithm associated with this object. As I mentioned before, the details of the algorithm are not important for this example illustrating countdown latches. And then the last thing we do is we go ahead and decrement the count, and this thread will then return, and then the main thread can proceed when the count reaches 0. Each time countdown is called, as you may remember, that decrements the count atomically by 1. So when the count reaches 0, the main thread can then pick up and keep doing whatever it was doing. So that's the end of the Countdown Latch example application. We'll show this application in a different variant shortly when we talk about cyclic barriers.